Alright, very good day to you here. As you can see, this is the lesson that we have of simple circuits on simple circuits. I'm going to continue with part 2 of simple circuits. So make sure you do follow with me on this. I need to turn to page 221, page 221 of your textbook. As you can see here, this is on current electricity. And just a little bit of flashback to what we have done previously. We have looked at the electrostatic attraction or static electricity. There is a difference between static electricity and the electric currents that you have in your house. But the principle is still about the same. If you still recall what we have done on static electricity, you still remember that electrons can move. So if you talk about the basic structure of an atom, it consists of neutrons, protons, and electrons. As you know that the core or the nucleus of the atom consists of neutrons and protons surrounded by electrons. So the whole principle that we have is that electrons can move from one atom to another. So when we talk about electricity here, the one that you have at home right now, it is the flow of electrons. So I highlight this for you. It is the flow of electrons. And it says that which is the flow of negative charge. So I've highlighted this for you. So when we talk about electricity that you have at home right now, when you turn on your light bulb, for example, it is a flow of electrons that enable the electricity to be conducted. So it says these flowing electrons carry energy that is transformed into other forms of energy. So I'm reading the second sentence for you. Transformed into other forms of energy as the electrons pass through things like light bulbs, heating elements, and motors. So for example, when you turn on the light bulb, when you push the switch and you turn on the light bulb, the electric current has been transformed into light energy. As you can see, when you turn the light bulb, it lights, and it will also produce other energy such as heat energy. So when you touch the light bulb after a period of time, it will be quite warm because the energy that you have has been transferred into these different forms of energy. So light energy for the light bulb when it lights up, and heat energy when you feel the warmth of the light globe. Alright, if you look at this diagram that we have here at the bottom, you can see that this tells you how electron can flow. So the whole principle or the whole idea that we have is that electrons can flow while protons and neutrons can't. So electrons flow from one atom to another. So for example, if the first one is this is one atom, as you can see, a flow from this atom to the next atom, to the next atom, to the next atom, and so on, and that allows electric currents to flow. Alright, so what you need to get out of this slide is that electricity is a flow of electrons, and electrons can move. And in this case, electrons is the one that allows the light bulbs, for example, that you have at home to be turned on because of the electron flow. And going back to what you have done previously on static electricity is about electricity that can't move, but electrons does move in that sense. Which is why if you rub one, let's say balloon with another balloon, electron is the one that is moving from the first balloon to the second balloon. So I'm going to move on to the next slide, moving on to the next slide. So this is on simple electric circuit. So the remaining part of the chapter is on what is a simple electric circuit and how does it look like. And later on, if I do come up with some materials, I will be showing you on how an electric circuit looks like. So electric circuit, as you can see here, I'm reading the second paragraph for you. So electric circuit needs an energy source, So at home right now, you should be able to find a battery. I'll change this to a highlighter. Maybe that's a little bit better. So an energy source such as battery, power point, or a generator like the dynamo on a bike. This supplies the electrons in the wire with the energy they require to get them moving around the circuit. Which is why if you have, let's just say anything really, if you have anything that is even powered by batteries, for example, you may have a toy that is powered by batteries, a mechanical car, for example, you find the energy it needs to have an energy source. Without the energy source, the electric circuit is not complete. Alright, so think about this. The second is an energy user such as a light bulb, heating element, resistor, or motor. These devices convert the energy that electrons are delivering to them. So I'm looking at the second sentence here. So you do need a light bulb in this sense because you want it to be transformed. You want the energy to be transformed into another form of energy. So it doesn't really make sense for the energy to be kept the same. You can't really see anything from it. So it can either be changed into heat energy, it can be changed to light energy. So if you have light groups at home, once again, it will be transformed into light energy. If you have, let's say, a toaster, it will be transformed into heat energy. Alright, and you have wires that connects everything together, making the circuit complete. So think about this. What you are talking about electric circuit. Each electric circuit, each complete electric circuit that you have must have an energy source, an energy user, and wires that connects everything together. And this will bring you to the next slide. So I will show you. This is from your textbook. As you can see here, a circuit needs energy source, energy user, and wires to connect them. Or the circuit usually has a switch too. So you have a switch, you have an energy source. I will highlight this for you. So you have a switch, you have an energy source, in this case it's a battery, you have an energy user which is a globe, and you have wires which completes the circuit. So this can be an example of a simple circuit. So I'm going to move on to the next slide, moving on to the next. Alright, so I'm going to continue with the circuit components. So it says here we can represent circuits and their components with circuit diagrams. There are a few important circuit components that you need to know the symbols for. This will allow you to draw a circuit diagram. So based on what we have discussed previously, there's 3 different parts that you need to know for a simple circuit to work. Number 1, you need to have your power source, as you can see here. Number 2, you need to have where the energy has been transferred into, in this case a light globe. And number 3, you need to have wires to complete the circuit so that it works. So as you can see here as well, we do have this particular switch that is able to turn the electricity on and off, which is something common that you find at home as well. Every time you turn on the switch for a light globe in your room or at your house, it will enable you to turn it on or off. Otherwise it will be on all the time, and that's not something that you want. Alright, so this is on the circuit compound. I'm just going to move on to the next slide. Alright, so this one here shows you what the symbols you need to use when you draw a simple circuit. So at the end of today's lesson, you should be able to draw that simple circuit using these symbols that we have. So you have a connecting wire, light globe, switch that is open or closed. You have ammeter, voltmeter. We will discuss more about ammeter, voltmeter in the next lesson, but in general principle here, ammeter is used for you to test the electric current, voltmeter is to test the voltage of the circuit that you have. You have your cell, you have voltage supply, you have your resistor, which has the resistance that you have in your simple circuit. Once again, we will discuss more about ammeter, voltmeter, and resistor in our next few lessons. But for now, you need to know how to draw these symbols and put them together for you to draw identify your simple circuit. So I'm just going to move on to the next slide. So circuit diagrams, you say a circuit diagrams is a simplified and shorthand version of a real circuit. It shows how all the components in the circuit are connected. A torch is an example of a very simple circuit. Its energy source is a battery and its globe transfers electrical energy into light. The battery supplies the electrons with energy. As the electrons flow through the globe, it loses almost all their energy, which is transformed into light energy and some heat energy. The electrons then travel back to the battery where their energy is replenished. Alright, so when we talk about a simple circuit, once again, you're talking about transforming into a form of energy that can potentially be useful for you. So once again, you think about the light globes at home. How does it work? It needs to come from an energy source. So once you have your energy source, once you have your circuit that is completed through the wire, and you have your light globes, you are able to transfer the energies from one to another, in this case, into heat and light energy. Light energy is mostly what you want. And it says that electrons are travel back to the power source where the energy is replenished. So this is the general idea of a circuit diagram. Think about that. Anything that you do at home when you are trying to turn on something, an equipment that's generated by electricity, the whole principle will work, this principle will work for that. So I'm just going to move on to the next slide. Alright, so once again, you have your circuit diagram. Let's say you have your torch. We have two batteries here. So you have your simple diagram here, simple circuit diagram here. So it shows the battery source. So I'm just going to highlight this for you. Okay, I'm just going to do a circle here. So this is your battery. You have your light globe, which is somewhere at the top. I'm just going to use a different color so that you can see the difference. So this is your light globe, and we do have this particular switch that is able to turn the circuit on and off. So this is your switch, and you can connect the whole thing through wire. And once again, this brings you your simple circuit. Once you're done with this, make sure you do complete the review questions based on what has been assigned on school board. So make sure you do complete those review questions. And addition to term 2, I have also added a weekly quiz. There is a weekly quiz that you need to complete on school boards. Make sure you do complete it on time, and you'll be assessed, you'll be marked as part of your classwork. So make sure you do complete on time. Once again, any questions, you're very welcome to post here onto school boards, and I will see you in the next session. Thank you very much.